Okay, a very good day, everyone. My name is Shoei and I'm co-founder of EdXP. I believe all of you here should be familiar with me because I do see some familiar names. That means that you guys have probably seen me presenting in last week's Econs seminar or being present as well for the TOK and Math webinar. If not, you probably will have received emails from me if you're on mailing list. Okay, without further ado, as promised to you, today we'll be focusing on chemistry IA. This is going to be one of the many webinars that we will be conducting, a series of webinars that we'll be conducting over these few weeks. And today I'm very happy to introduce two of my colleagues, Richard and Benjamin. Okay, for the purpose of Chemistry IA, we have both of them who will be presenting to you all the tips, tricks, and strategies you need to know to do well for Chemistry IA. So just to let you guys know, both of them are actually former IB students. I will leave it to the both of them to introduce themselves to you. Okay, Richard and Benjamin, can you take it from here?
All right, thank you, Shoei. So I was an ex-IB student I took the exams in 2020, and my subject combination was physics, chemistry, and mathematics HL, and Langley economics and Chinese BSL. So I scored 44 points with 7 in chemistry. Now I'll hand over to Richard to give his introduction before I continue.
Okay, hi everyone. So I was a November 2020 IB student like Ben, and yeah, I scored 44 as well, 7 in chemistry, and Ben and I, we were actually from the same school, and yeah, we did our chemistry E together. We spent a lot of time in the lab together.
So first, to give some scope to this presentation that we'll be giving, so we'll first go through some introductory tips for the chemistry IA. After that, we'll go through the assessment rubric as well as the steps to approach the IA. After that, we will give you some potential research questions that you guys can consider. And after that, we'll go through one IA example that we feel is quite good, and there are some pointers which you guys can learn from it. After that, we'll go through some FAQ and any questions that you guys may have. Yeah. So to introduce the Chem IA, it basically allows students to explore the chemistry syllabus outside of exams. That is the key of IB, right? Because IB specializes in a lot of projects along this 2-year program. And basically, this IA is for you to explore chemistry outside of the classroom. And it should cover a topic that basically is still within the IB syllabus, the IB chemistry syllabus, but extended maybe a little bit just to write this IA. It is mandatory for both SL and HL students, and it contributes to 20% of your final assessment in the IA. It should be around 6 to 12 pages long, and and the allocated time based on the IB rubrics is about 10 hours. Yeah. This 6 to 12 pages long is just a guideline. Basically, you guys should try and write as concisely as possible because there will be marks taken away from you if you guys write too long and if it's not easy to understand. Also, for HL and SL, they're basically the same IA requirements. The rubrics are the same, but however, as SL has a smaller syllabus coverage, maybe the topics, some HL topics may not apply to SL as much. Yeah. Okay, so first thing I would like to bring in is about academic honesty. Basically, especially when it comes to research, there's basically a lot of research that has been done for chemistry already. And whenever you guys use other people's research, it is very important that you guys cite whichever sources which you use. Other than that, the teachers will guide you guys through one draft of your work. However, they'll be here throughout the whole process of your IA from start to finish. One point on this guidance from the teachers, right, is that basically the teacher is the one who will be with you throughout your whole IB chemistry journey. And they will be the ones who will be able to best advise you on how to proceed if you guys are stuck. Yeah, as ultimately they are the ones marking your IA. Another thing, so this is a warning saying that basically if you guys are found out that you guys are being academically dishonest, it may lead to your IB diploma being withheld or revoked. Yeah. Okay, to continue about this, for the chemistry IA is unlike other IAs where actually collaboration is allowed. But a point to note here is that collusion is still academic dishonesty. The difference between collaboration and collusion is that collaboration is working together to reach a common goal, while collusion is working together with the intent to cheat and deceive to their own advantage. So while collaboration is encouraged for this chemistry IA, but collusion is not. Okay, so on to the next point. Actually, students will be able to allow to work in groups for collect their own data. To give an example, some IAs require a lot of data to be collected, where many replicates have to be generated, and each experiment will take maybe the whole day's work. It might not be feasible for one student to complete the entire experiment on their own. Hence, multiple students can work together in pairs or work together in pairs to collect multiple sets of data themselves and combine with the other students' data to form this IA. However, a point to take note is that if you guys do this, it must be clearly stated which data was collected by you and which data was collected by your friend. And another thing is that the final report, the analysis, the data processing, and the graphs must be done individually, which means that you guys cannot work together to write the analysis and your conclusion, even though the research may be the same. Okay, another point about the chemistry IA is the HS&E considerations, which basically mean the health, safety, and environmental considerations. Before starting this IA, an important thing to take note is laboratory safety. There are many chemicals that you guys may use which may be dangerous, and IB wants you to take into account to take your safety into your own hands and be aware of what safety procedures should be used to use certain chemicals, such as dichloromethane, where you guys must use the fume hood, or certain personal protective equipment, such as gloves and goggles, when you guys are using irritants or other toxic chemicals, which states here. Basically, you guys will be able to find this out in the MSDS, which is the Material Safety and Data Sheet, which can usually be found online if you Google the chemical name MSDS. Basically, this HS&E considerations should be incorporated into your methodology. Yeah. Oh, if anybody has any questions at any point in time, please feel free to message the chat. My colleague Richard will reply you in the meantime. Okay, so now onto the assessment rubric. It will be 20% of your overall chemistry score, as I mentioned, and it will be 24 marks total. There's 5 key components: personal engagement, exploration, analysis, evaluation, and communication. So for personal engagement, it basically assesses how you bring chemistry in your day-to-day life, how you are able to see the chemicals which you use on a day-to-day life and expand and explore these chemicals to be used in your IA. Yeah, so it also assesses how creative you are in thinking about this research topic, like based on whatever you guys see, or maybe some real-life applications of the chemicals that you see, etc. I'll go into this more when talking about the actual IA. The next section is on exploration. So this exploration basically emphasizes on the scientific context of your work, and it basically this section is based on your theory, the theory behind your IA. What goes into what are the theories behind your hypothesis in your IA? It also evaluates whether you evaluate the health and safety of the chemicals you use. As you can, yeah. So another thing is that it also assesses how related, how if the concepts are connected to the IB syllabus. Yeah. The next section is on analysis. So this section is basically how students record, process, and interpret the data based on your RQ, and whether this data will be able to support a conclusion. As you can see for the 5th and the highest mark criterion here, it basically assesses you on the methods which you use to process and analyze the data, as well as the considerations you put into your methodology. Yeah. And the next part is your evaluation. Basically, this part assesses the part after you process your data, how well you are able to analyze your data and link the information you wrote in your theory, the exploration, to your conclusion. Basically, how well the theory you mentioned can back up or can agree or disagree with whatever you bring out in your hypothesis. Yeah. This is the maximum marking group. Okay, so for the last criterion is what I mentioned previously, which is communication. It's basically how well you are able to write how clear and how concise you can be with writing your report. Basically, an easy way to find out whether you are clear and concise is to have your peers read it. Even though you guys cannot copy from each other, I recommend that you guys can show your report to your peers. And if they are able to understand what you're saying, it is a sign that you have written concisely and clearly. All right, after the rubric, so now I'm moving on to how we can approach the IA. So first is topic selection. There's so many topics in chemistry. How do I even pick one that suits me? And even if it suits me, how do I come up with what dependent and independent variables, right? So there's a step. These are the 3 steps that we use to formulate whatever RQ that we have. So first is that we look for chemicals that can be applied in our real life. For example, in your beauty products, there's a whole list of chemicals that you can take from. Otherwise, there's also food and drink. For example, caffeine in tea or proteins in food that you eat. And you guys can relate it back to the things that you use these food with. For example, how long you cook a certain food. How will it affect this certain chemical in it? Other than that, you guys can also explore other ingredients such as preservatives, ingredients, and you guys can bring out some real-life applications of certain chemicals. After that, you guys should do some research into this specific chemical or group of chemicals and find certain things that will interest you. And lastly, you guys will think of a potential independent variable which you guys can change and draft potential experiments and RQs which you guys can use in the lab. Another thing that you guys should take note into here for this is that you guys should you guys should go down to your school's laboratory to see what chemicals and what equipments that the school has, because you might be able to think of a really good RQ, but then if your lab doesn't have the chemicals to support your experiment, you guys might have to buy the chemicals, which honestly will be very expensive depending on the rarity of the chemicals. Another thing is that the methods which you guys use, right, they may be very difficult to replicate in the school laboratory. For example, if your chemicals are heat and light sensitive, or if you must leave your chemicals for really long periods of time, it might not be feasible for you to do these kinds of experiments within the school laboratory. So I suggest before you guys even settle on an RQ, you guys should think through your experimental procedure to make sure that at least in your head it will work out before you guys settle on it. Yeah. Okay, so here are some past IAs that we have compiled from our library, and here are some good RQs based on the different topics in chemistry. If you guys have any questions, feel free to ask. I won't go through unless you guys have anything. Yeah. Okay. So moving on. after you guys think of our RQ, you guys will, as I mentioned, a school lab is actually very different from whatever you theorize at home sitting at your desk. So the first thing that you guys will need to do is to conduct a trial experiment based on your trial experimental procedure and determine whether it is feasible, whether you guys can actually do it within the laboratory. For example, if you guys are using a light sensitive, oh, sorry. Okay. Is this back? Yeah. Okay. Yeah. So if you guys are using a light sensitive ingredient, it might degrade before you even get the chance to use it. Hence, it might not be actually feasible. Or if it really degrades, you should find some adaptations that can be used in your lab to protect this chemical before you guys use it. And which brings me to my next point, which is the adaptations. You guys will have to adapt your theorized experimental procedure to optimize it for the current lab that you're at. Because every lab is different, every lab has different chemicals, and also the equipments are of different standards. Some might be older, some might be inaccurate. You must choose your equipment as well as your procedure wisely before you proceed to data collection, because it will really affect how well you are able to see a trend after you process your data. Yeah, so after you adapt your procedure, you move on to data collection. A minimum of 5 data points and 5 replicates is required to establish a trend. Be systematic in recording your data and take photos of your observations or even your preparation steps. Any qualitative observations you make from your experiment should also be included, as it is good to include them. Yeah. All right. So on to writing the actual report. So here are the 9 key things that you guys should include in your report. First is your introduction. Basically here, you introduce your RQ and basically bring in the personal engagement, which I mentioned previously. Why do you want to use this chemical? What real-life applications does this chemical have? Or where do you see this chemical in your in your life? Yeah. And how you came about your RQ. After that, you explain the possible concepts behind your RQ in the background. For example, if your RQ is about how temperature affects caffeine in a liquid, you might bring in the solubility of caffeine or some thermal degradation concepts within this background. You should explore the different concepts that might influence the results of your IA, even though it may not be stated in your RQ. After that will be your experimental procedure. It is best for you to state this in a step-by-step procedure, and it is clearer that way. Also include a table of variables, what I mean by this is basically include a table stating your independent, dependent, and controlled variables. And for your controlled variables, do state how do you control, what are the methods we should use to ensure these variables are controlled and stay constant. After that will be your results. So as mentioned, please include any qualitative data through photos if possible. Yeah. After that will be your evaluation, which means the processing of your data, the calculation of your uncertainties, as well as summarizing your key findings. Basically, this is where your background will come in and be combined with your results. This is because your hypothesis may not always be correct, and however, there still should be sufficient theory to back up whatever trend you see after you process your data. Yeah. After that, which is your conclusion, is where you will answer your RQ. Whether the trend you hypothesize in your RQ is is true, or is there an alternative explanation and an alternative trend? This will be all included in the conclusion. After that will be the errors and limitations. So over here, you guys will explain the systematic as well as random errors that might have occurred during your experiment. Other than that, you guys will also mention the limitations, possibly due to the lack of equipment in your lab. You guys are unable to follow certain, you guys are unable to do further analysis on your product or continue your experiment. Yeah, which leads to the second last group, which is the possible extensions. So these extensions basically is how can your RQ be further developed, in the sense where what things could you not do in the lab and you guys will be able to do with possibly better chemicals, more equipment. These kind of things can be put in the possible extensions. Lastly is your references and appendix. This is important because of academic honesty. Whatever sources which you use, please cite accordingly throughout your IA and you guys should ask your teacher what reference style he or she wants you guys to use, ECS, Chicago, etc. You guys should find this out from your teachers and cite accordingly. Also, for data sets that might be very lengthy and very long, you guys might want to move them to the appendix if it breaks the flow of the whole IA. Yep, now I'll be handing over to Richard, who will be going through one IA from, yeah.
Okay, I think I can share my screen on my side. Give me a second. Okay, can everyone see it? Can, right? Okay, great. Yeah, so this IA that I'm going to be sharing, we're going to be putting all this theory that you've learned. It's like, oh, what's this process of doing this IA? And we're going to put it into practice. And we're going to I'm going to show you this IA, which was actually my IA from my time in IB. And these are real IB marker comments from my chemistry teacher. So yeah, it's not a perfect IA. I think it's a pretty good IA, but let's have a look at it. So yeah, I'm going to explain a little bit about how I came up with this topic. It was actually it was a failed bio IA topic about yeast, and then I got curious about how yeast might affect the nutritional content of bread and so on and so forth. So I went on this really deep rabbit hole about yeast, and then I saw that it affected it digested phytic acid or something, and then this phytic acid affected iron content or whatever, and I went on this rabbit hole, and so I found this this gap in research, right? There's phytic acid, which we're interested in, and iron, right? But there hasn't been that much research between these two specific chemicals, phytic acid and iron. So yeah, this was an area that I was interested in, and I wanted to explore it further in my eye. And so if you can see the research question here, how does the pH affect the ability of phytic acid to be extracted from atta to chelate Fe3 plus ions from prepared iron 3 nitrate solution as measured by UV-Vis of the remaining Fe3 plus ions complex with SCN minus ions. Right, so sounds long, but essentially how does pH affect the ability of this chemical phytic acid to sequester or chelate Fe3 plus ions? Yeah. Okay. So it relates to chemical equilibria, acids, bases, salts, and chelation. Okay, if you look at the comments here, these notes, the 2EX, for example, that means criterion 2 exploration, yeah? So under exploration, topic is clearly defined and the fully focused RQ is clearly described. Candidate shows clear focus on why he wants to do this investigation and able to relate this back to the RQ. RQ is not commonplace or has a very obvious outcome. The scope is not too vague nor straightforward. It is worthy of investigation, evidence of significant independent thinking, and signs of creativity. So if you refer back to the rubric from earlier on, these are all things that would score you points, right? A good explanation on how there's anemia and so on and so forth, and inorganic iron is vulnerable to sequestration by chelating agents such as this thing in this chemical that people eat commonly in atta flour in India, right? And yep, so you can move on to the next slide. Right, so intro, we're done. Background info. Background info, earlier we were talking about what methods you use to conduct the experiment and why, right? And this particular case, I'm talking about buffers and maintaining pH levels, and this relates to controlling the independent variable, right? So we're changing the pH, and this is how I'm intending to change the pH using this particular mechanism here, right? So here it says showcase the planning and of the experiment and considerations of the external factors which may affect the experimental outcome. Consideration of choice of the chemicals. Yeah, and so I explained why specifically sodium phosphate buffer. Yep. So next, right. So this is a quick rundown of the analysis method. So this relates to the dependent variable. I'm talking about chelating iron, right? So how am I going to measure this amount of iron chelated? And my conclusion here, I'm using thiocyanate. Yeah, the thiocyanate ion, which I talked about in my RQ earlier on. And this is there's a comment here. Good example of a methodology overview. Variables were well managed. Procedure was written with the appropriate amount of details. And so this is all theory. We haven't gone to the actual methodology yet. This is right at the start of my thought process, like, oh, this is how I'm planning to do my experiments. This, in theory, this is how it would work. Yeah, this is chosen over EDTA titration because of what? So this is personal engagement as well. Okay. So next, I talk about deprotonation of phytic acid. So this is more background information. So what impacts do the independent variable have? Earlier on, I was talking about the buffer and how I control the independent variable. And now I'm talking about how the independent variable may affect phytic acid, which is the chemical I'm interested in exploring. Yep. So here there's a diagram of phytic acid to phytate, and phytic acid, as the name suggests, is an acid, right? It can lose 12 hydrogen ions, 12 H+. And it's in dynamic equilibrium, which is shown by these two double arrows here. Yeah, so this is all relevant. All right, sorry. Yeah, so the shift, this relates to chemical equilibrium, because when you remove protons or H+ from a solution by making it more alkaline, more basic, the equilibrium will shift towards the right. And if there's more acid added, it's going to shift towards the left, right? So not to worry if you haven't learned this, but this is part of chemical equilibrium. So I have this graph here, which I cited. Previous studies, right? So this is this again is impact of the independent variable. What impacts do the independent variable have and why? So past research states that phytic acid's ability to chelate other metal cation ions, blah blah blah. Right. So past research we've done a lot of research on metal ions, right? And this is like sort of like, and it's not really a hypothesis, but this is if it affects other metal ions in this way, maybe it would affect iron in this similar way as well, due to the increase. Dependent on the number of, so it's dependent on the number of deprotonated groups, which we were talking about earlier, right? Which is affected by pH. Yep. And in the next slide, sorry, just to continue on, sorry, let me just backtrack a little bit. Yeah, so the increased number of deprotonated groups will increase the number of lone pairs, which relates again to the chelation of Fe3+. So the link here is, the link here could have been stronger, right? And next. So this is another effect. So this has to do with organic chemistry, the conformational changes caused by the deprotonation. So again, it has to do with the independent variable. And this is also VSEP. This is also VSEPR. It's not explicitly stated here, but VSEPR concepts come into play. So again, existing research. Yeah. Okay. So this is an analysis method. Again, we're talking about iron 3, right? The solubility of iron 3. So I talked a little bit about the considerations for experimental design here, and it relates to one of our constant variables. This is one of the constants I had, right? Iron 3 hydroxide is widely considered to be insoluble. So how am I going to make a solution for my how do I make a standard solution to chelate this iron away when I'm making a basic solution, right? And this is how, and also this relates to how the independent variable affects the dependent variable, right? How pH affects how pH affects the amount of iron left in the solution later on. And so this is yeah, if you see the comment here, the background given into the possible factors affecting the dependent variable, personal input on experimental design again. So this, because this iron 3 hydroxide being insoluble, I had like this theoretical improvement, right, to use acid to solubilize it while taking advantage of the time to reestablish equilibrium. So this is under personal engagement again, because there's personal input to the methodology. It's not like I just plug this methodology from some website. Yeah. Okay. Hypothesis. So this was actually one of the weaknesses of the IA. As you can see from the comment here, the hypothesis doesn't mention phytic acid, right? So the problem here is that the hypothesis and the RQ are not explicitly related. So on my marker side, there was a bit of a worry that I may present research that's not really relevant to the initial research question. So I didn't in the end, but this was one of the comments, negative comments, and and yeah, the chem and apparatus list is this is already under methodology, by the way. So the chemistry and chemicals and apparatus list. So where you're expected to write down a full accounting of the chemicals and apparatus. What chemicals are you going to use? What apparatus are you going to use, including errors for error proposition later on, so that the marker can keep track of that. Okay, next. Okay, methodology here. Right. So so here we will look at the first line. Glove, safety goggles, and the laboratory coat were worn during all experiments. So this the comment from the examiner here was that safety concerns lack specific reference to the chemical or conditions used in this investigation. Additional safety measures could have been mentioned for the chemicals. So this is frankly, it's a generic statement which doesn't add that much to the IA. So this is also one of the flaws. Yeah. Okay. So under trial experiment. So this is where I really describe my thought process. Like, oh, what is this thing that I did? I used a large excess of phosphate buffer to achieve the desired pH. PA extract was then allowed to create a known excess of Fe3 plus and centrifuge to remove insoluble, yada yada yada. Right. And then I described some problems that I encountered. Right. So for example, I initially wanted to do nice pH values. You look at my research question, why 1.67, 2.63? They're really random, right? But they're not, because I wanted to use pH values that were easy to set up using these buffers, right? Because these pH values were close to what we call the pKa. So this made for better design of the experiment, and I justified it over here. Yep, and pellet after, right, and after I tried to like do all this fancy centrifugation stuff. Sorry, previous slide. yeah, I realized that, oh, there's a problem here. So the general flow of this section should be observation and what observation. So this is a possible problem that I may encounter, and how do I improve on it? So you see that I was awarded marks for personal engagement here. So this shows evidence of you being invested in the methodology of the IA. So earlier on we were talking about independent, dependent, and controlled variables. So yeah, so this is quite self-explanatory, and the comment here, independent, dependent, controlled variables clearly stated. So not an issue. So this significance column, I want to bring some attention to it. So it's really for the constant variable. How do you intend to control this constant variable, and how does it impact the results? Why is it important to control this particular variable? Yeah. Okay, next slide. Okay, so I haven't like presented all the experimental procedures because frankly it's you don't need to know it. But so the point here being don't write in prose, use numbered steps. So this makes it easier for the reader. And yeah, there's one comment here, evidence of awareness of safety and environmental issues of the methodology of the chemicals used. So this thing about toxic vapors. So where did I get this? I got this from the MSDS, the material safety data sheet that Ben was talking about earlier. So this is important because sometimes your teacher will ask you to produce, oh, what are the hazards of the chemicals that you're working with. So you need to be able to answer your teacher, not just because your teacher is asking, but you want to be safe in the lab. And you're also going to have to write it into your procedure to show that you've read the MSDS, you've considered this issue, and yeah. And it's okay to have a table of health, safety, and environmental considerations, but personally, I prefer to write it into my experimental procedure where it's relevant. But this is sometimes your teacher may have a preference on that, and you should listen to your teacher. But yeah, that's my preference, and that's my teacher's preference as well. Okay. So so again, more experimental procedure. Another comment: procedure clearly presented, but the sequence of steps can be phrased in a clearer manner, mentioning important keywords and relevant. So this is about phrasing and whether it's understandable. So I did a pretty good job here, but apparently not good enough. So what you can do to spot these kinds of errors is, again, give it to a friend. Can your friend understand it? If your friend can understand it and they're not like a super genius or like a PhD student, you're good. Yeah. Okay, photos, great. Pictures of qualitative data are great. It shows evidence that you were in the lab, and it gives an idea of like, oh, what is it like to be in what are you expected to see during this experiment? What is it like to be doing this experiment on your own? And yeah, it says here sufficient qualitative data provided, which aids the understanding of the investigation. So not just photographs, you should describe the photographs. What is this color change, right? So that was that's qualitative data. And next, quantitative data, right? So quantitative data, there's a minor error here, one decimal place. So this was for my standard curve, right? It is still part of my methodology. Sorry. Okay, next slide. So here, there's another error, should be 100 divided by 1000. Calibration data plotted into a well-drawn graph. So this is a warning, not a warning, but I guess a note to double and triple check your math, right? Because sometimes there's small errors here and there which could cost you a couple of marks, which is not worth it. Yeah. And calibration graph. This max min slope or min max slope is for error propagation later on. So if you're using the UV-Vis spectral photometer, this is something that you're going to have to use. This is something that you're going to have to do. Okay, next slide. Okay, again, double, triple check your math here. So the volume doesn't tally. I got a few marks deducted here probably, but but it's not so bad because the overall error propagation steps were done correctly. So what you want to do here, what you want to do when processing your data, you want to show a sample calculation. So you're not gonna, you have 5 data points plus times 5 repeats, right? That's 25 times. You're not gonna do 25 times of the same calculation because there's gonna be a whole IA gone. So what we normally do is we show a sample calculation, the first replicate of the first example, and we show the error propagation there. And you do the rest on your own. You can choose to include it on your appendix, but most people don't, and it's completely fine. And yeah, so that's data processing. Okay, so this is the next section, like my actual data. The previous one was just calibration data. So here, one of the issues that the examiner commented on was that the raw data was missing, right? So the raw data will be absorbance by the machine, right? But I went straight to the concentration of iron 3+. So this was an error. 3N, a sufficient number of repeats were carried out for each temperatures, and only consistent titration readings were selected for average. So these are all methodological issues that you should pay attention to. Evidence of full awareness of measurement uncertainty. Fantastic. Comment, data for negative control not shown. So this negative data, negative control that I was missing here is one where, how do I know that this phytic acid I'm extracting doesn't contain a little bit of iron on its own, right? Or there's no other effect messing with it if there's no iron added to it. So the negative control would have been phytic acid and no iron. So to test if there's sort of like a baseline absorbance that we should be correcting for. So this was missing here. Okay. Next. The consideration of uncertainties. Okay, so this was my data in graph form, this process data, right? Graphs properly plotted with appropriate axes and units indicated. Okay. Trend of data clearly explained. And by explaining the trend of data, that means is it a quadratic trend? Is it a linear trend? Is it an exponential trend? With a maximum amount deleted between here. If there are peaks, where are the peaks? For example, yeah, and the moderately strong correlation R squared. So these are all things that will be these are all things that are that you have to do. So this is the correlation coefficient. It's a measure of how well the data correlates with the trend line, right? And 9.39 is good. It's okay. Yeah, but it's not fantastic. So one of the comments here was that some consideration on the significance of the uncertainties was shown, but one thing that I could have done better was that you see these massive error bars. I acknowledged it here, but I don't explicitly say that this quadratic model may not be valid, right? So if any of you do stats, you know that if you want to draw a line through, like if you want to draw a trend line, it's perfectly valid to draw it any way you want, as long as it passes through all the error bars. Yeah, and there are many, many ways to do this, not just quadratic. So this is something that I could have acknowledged and done better. Okay, next discussion. Okay, the trend of data is clearly explained. Yeah, so the comment here, the trend of data is clearly explained. That means that the dips and the falls are all accounted for. If you look at the previous slide, why is there a dip here? Why is there a peak here? So I explained, this is because of the solubility of iron 3+, so on and so forth. And actually, I actually refute my hypothesis. My hypothesis was wrong. I believe that this solubility might have been a major issue, but it wasn't. It ended up not being a major issue. So this was something, and I discussed, why might this be? Maybe it's because of the speed of equilibrium, something like that. Okay, then next, deprotonation of PA. So this all links back to earlier what we were talking about in the background. You see these section names are the same. So in the background, I talked about how the independent variable will affect the dependent variable, right? So now here is how the independent variable actually affected the dependent variable. So conclusion was justified through relevant comparison of accepted scientific context. Yep. So same thing here. So early on we were shown, I was showing you a diagram of, we were talking about conformational changes. How does it change from one form to the other? And how does the pH affect this? And here I have this diagram that I took from a research paper and cited. Yeah, so this is the mechanism, and I explain it a little bit using the chemistry that I know. And related, of course, back to pH. Increasing the pH past 9 caused the decrease in the amount of chemistry calculated. Okay. Okay, so now we're at the conclusion. Conclusion was justified. Same thing. It's basically summarizing the past the discussion and what is answer your RQ, right? You've asked the question, answer it in your conclusion. So hence there is a broad pH calculating ability around pH 8 to 9, which is what my data found. Yeah, so detailed conclusion is described and justified, which is entirely relevant to the research question and fully supported by the data presented. So reflection of strengths, what went well, or the investigation were properly stated. So the reflection of strengths, don't be shy here. You did a trial experiment, you went through this whole process of refining your experiment, you made it great. So re-emphasize those improvements that you made from the trial experiment earlier on. So this is a time not to be shy. Yeah. So but here now you have to be humble, right? So methodological issues. So there's here I discuss about phosphate, how phosphate may mess with my data, and how I didn't have data points around pH 9 and 9.5. So these weaknesses and limitations are an important part. And yeah, so describe it in detail and discuss what you could have done to make it even better, right? So don't but don't discuss the obvious issues here. For example, like let's say I don't know, early on my solubility, right? So let's say I didn't think about the solubility at all until now. So now I won't really want to discuss it here because it seems kind of obvious, right? That if I have like little iron bits in solution, it would have been a clear issue. So don't discuss obvious problems that you failed to take into account, because that will just highlight your own failing. Instead, and suggest a fix that may be a little bit deeper than what you thought about in the theory. You're not expected to be perfect here. Your experiment is not expected to be perfect because you're working in a school lab. So yeah, go ahead, talk about your weaknesses and limitations. And then we have extension. So extension. So earlier I was talking about, I needed more data points around here. So this could have been done with a different buffer because my buffer was causing issues. And yeah, so clearly stated and explained. So that's fine. Okay, so here are some other marking points. Report is properly cited with the relevant use of specific terminology. So what the marker means here is that I use in-text citation, right? You see these numbers in the bibliography here. So these correspond to like little superscripts that I've been inserting throughout the IA. So for example here, this little 25 here corresponds to number 25 on the bibliography here. So this is known as the ACS, the American Chemical Society style of citation. So again, check your teachers. What style do they want you to do it in? Normally it's American Chemical Society, but it may vary from school to school or teacher to teacher. Yeah. And yep, there was a comment here within page limit of 13 pages. It's actually 12 plus 1. Yeah, it's actually 12 plus 1. Earlier on we were talking about 6 to 12 pages, right? It's 12 plus 1 for the bibliography. So again, listen to your teacher here. So sometimes they have they give a little bit of leeway. They give you 1 extra page for bibliography. Sometimes they don't. So listen to your teacher. Yeah, so there's a comment about structure and clarity and all that. Okay, so now we'll move on to the FAQs. Don't worry, we'll get to your questions later on, but these are some questions that we were anticipating that you might have. Okay, so difference between chemistry and IA and extended essay. So Ben and I both did both the Chem IA and extended essay, and frankly, they're more similar than they are different. But if we were to make a distinction, it would be that the E is meant to be an exploration or kind of like a research paper, whereas the IA is a lab report. So the level of detail that goes in is a little bit different. In the EE, you're expected to talk a little bit more about this background information, the existing research, and and the scope of the E is broader, and sometimes investigates two independent variables, mine did, and yeah. But the structure and writing process of the E and I is largely similar because the scientific method is the same throughout. Yeah. So how long should it be? Chem guide suggests 6 to 12 pages. This was what I was talking about. So typically, strong IAs have undergone revisions for brevity. So IAs that go on and on about one particular thing, repeat. They talk about this thing lots and lots of times. That's not going to be a strong IA. You're going to get marks deducted for communication. Right? IAs of excessive length will be penalized under criterion E. So you see here, sorry. Yeah, criterion E. For lack of conciseness. Okay. So how long should it take? It's difficult to give an answer because everyone's experiment is different. Oh, okay, sorry. To insert a little point here, right? Under a trial experiment, when you're doing an actual trial experiment, it's also good practice to think about how can I make my experiment a little bit faster? How can I make the replicates a little bit faster? So my first idea was to actually go and make bread, right? Because we're talking about flour and yeast and all that. But I decided not to do that. I realized that it was a huge time sink in the lab, and I could just extract the alphatic acid directly. So yeah. So don't do unnecessary things. You'll thank yourself later. Okay. So the guideline from IB is 10 hours of class time with approximately the same amount of time outside of class for students to develop their ideas and complete the exploration. Okay, so total 20 hours. So exploration in the title, nope. RQ is more than sufficient. Can students in the same school/class use the same RQ for exploration? Right, similar topics are fine, but the same RQ is not okay. And I actually want to touch a little bit on an earlier question about an earlier issue about the collaboration part with collaboration with peers. So Ben mentioned a little bit. Ben mentioned that you're allowed to collaborate on experiments, right? Gather data together. But this is but it's also important to know that this is very context specific, and in fact, IB discourages this. It's rare. It's allowed, but it's rare. So this most of the time is up to school policy, but you can ask the teacher about it. So if you have an IA with a big scope, for example, for some reason, it's okay to have to do data collection together, but you must really take great care to make sure that you're not writing the exact same stuff as your friend, because that may be considered plagiarism. Yeah. So yeah. Next, what should the target audience be? So I should be accessible for fellow students. It's not PhD thesis. I'm not expecting you to use graduate level chemistry. Yeah, nobody's expecting you to do that because you're an IB student. So if your friend has no idea what what you're talking about, it may mean that either your writing is not good, or the chemistry that you're using is too sophisticated to be explained concisely within this IA. Okay, can students use chemistry that's outside the syllabus? Yes, as long as the chemistry is fully relevant and clearly explained. Not necessary, but I did it, and it was fine, and it was fully explained in my IA. That's the most important thing. Your friend must be able to understand. what constitutes good citation practice? So this is quite important. Essentially, whenever work ideas or images that are not your own or common sense, I guess, like if you're writing the sky is blue for some reason, you don't have to cite that. But otherwise, if you're talking about deprotonation, you're gonna have to cite a source. It's not common sense, and you didn't come up with the idea of deprotonation, right? So, and it's not enough to just give like a big reading list, like throw it at examiner. Go figure out where, like, this is a list of 10 books. Go figure out where I got it from. So that's not sufficient. You will have to cite sources at appropriate times in the I using in-text citation, like the superscript of numbers I showed you earlier. Yes. Okay. So this brings us to the end of our presentation. Okay.
Okay. Thank you so much, Richard and Ben. So if you guys have any questions, feel free to ask in the Q&A section. If you have any questions, it may not necessarily be related to chemistry. It can be for anything related to your IB. As long as we're able to help, we will try our best to help you. So just to let you guys know, I think that those of you who have joined us earlier, Richard and Ben, they are former IB students. They both scored 44 for their IB, and they're actually a member of the EdXP team. So for those of you who have tried the EdXP platform or who have subscribed to our services, the questions were actually created by all of them. Okay, so they're the guys who have been working really hard behind the scenes to create the questions that you guys are using on EdXP. Okay, so if any other questions not relating to chemistry, we'll try our best to answer as well. If not, we're just gonna hang around for another like 5 minutes just to see if any one of you is gonna has anything for us. Okay. Actually, I have a question, right? Maybe I can ask Richard and Ben. Since both of you scored 44, what was the 1 mark that was lost from the 45?
TOK.
TOK. Ben?
Same actually.
TOK.
Oh.
Okay. Right. Okay. So we're not trying to address any TOK questions for this seminar.
Yeah.
Okay. So we have a question.
How can I develop a fully focused research question? Okay, great. Let's go back to my slide, which was 21. Okay, so let's look at my RQ, right? So here I talk about pH affect the ability of phytic acid to extract phytic acid extracted from atta to chelate Fe3 plus ions from a prepared iron 3 nitrate solution as measured by this. So if we break down this particular research question, you see a few key aspects to it. So how does the pH? So this is actually the independent variable affect the ability of phytic acid extracted from atta to chelate Fe3 plus ions. So that's the dependent variable here. So independent, dependent, and prepared FeNO3 solution. So this is one of the this is the methodology. This part of the methodology as measured by UV visible spectral photometry of remaining Fe3 plus ions complex with SCN minus ion. Sorry, that's a mouthful. So independent variable, dependent variable, and the methodology. So just like a brief overview of the methodology, right? So this is a question that sometimes it actually might help to write your to begin writing your IA first, and then come back around. What question are you answering? But you might just be playing around in the lab, and then you have a bunch of data, and you realize that, oh, this I actually answered this. My data actually leads to this particular conclusion and answers this research question. Yeah. So it all comes back to the same thing. You've been doing it since middle school or maybe even primary school. Independent variable, dependent variable, constant variables. So think about it in terms of these three sorts of variables. Sorry, Ben, do you have anything to add?
No, that was yeah. That was basically what I wanted to say now.
Okay. Great.
Okay, maybe I'll just ask a couple of questions, right? Okay, we have a question, and I think it's a good opportunity for you guys to share your experience.
Mm,
Ben?
okay, I'll go first. So my subject combination was PCM for HL, which are physics, chemistry, and math. And my SLs are econs, Langlit, and Chinese. Richard?
Yeah, my HLs were bio, chemistry, and math, and my SLs were history, Chinese, and Langlit.
Okay,
Yeah.
so the question I would like to ask on behalf of the attendees here, I believe most attendees here are probably taking the May 24th paper. So this means that they are actually going to start their summer break right now, right? So they are going to probably end DP1, have a 3 months break, and then they're going to continue with DP2. How would you guys advise the DP1 students who will be having a short break before they commence DP2? What would you advise them how would you advise them to spend their time wisely, or what do you guys do during the transition from DP1 to DP2?
Okay, well, Ben and I spent a lot of time in the lab during our break between DP1 and DP2.
Yeah, we spent a lot of time in the lab. But
yeah.
Okay.
Was that because of the IA or EE?
No, it's because of the
both.
E.
Both for me.
Yeah, actually, mostly E for me, but I think both for Richard.
Right.
Mm.
Actually, I also want to say that I think IB isn't like the be all and end all. I mean,
yeah,
it's great to have that 45, but also sometimes you want to think about if you're planning on applying to a competitive university, what can you do on your own time that fits your interests, right? So IB is great, but that's not the only thing that matters. But that being said, if you're weak academically, it might be worth taking a look at maybe your proportional exams, or I'm not sure what you guys call it, but from DP1 to DP2, what are the areas in DP1 that you haven't done so well in, that you're not confident in, and perhaps brush up on those, because IB is a fast-paced program. They're not going to reteach everything in DP2.
Yeah, I actually agree with what Richard said. For me, actually, I spent quite a lot of time in the lab, and looking back on it, I regret a little bit that I spent so much time fussing over this one EE. But the thing about IB, right, is that IB teaches you how to multitask between a lot of different things. And if you cannot do it, means you cannot do it. It doesn't, the fact that you cannot that you cannot complete it doesn't mean it's the end lah. There's a lot of other things that will contribute to your overall IB thing, to your overall IB diploma, and this one setback will not determine your future. Yeah.
Safe to say that we spend a lot more than the advised 10 plus 10 hours.
Yeah.
Which is frankly overkill.
Yeah, exactly.
Okay, I think there's a question about physics, right?
So for physics, how do I manage the content and get around the questions? Okay, so for physics, I think physics is a little bit different from chemistry, because at least for chemistry, past a certain point, the topics are very contained and the questions are very similar. But for physics, it's a bit more like mathematics lah. Basically, because you can expand on the certain concepts, and they can really come up with some really tricky questions that will get you down and very confused as to what they're asking. I actually struggle a lot with this for physics, but I think the key thing for physics, right, is that there are a lot of questions that will repeat themselves over the years for physics, and you should focus on being able to answer them. And also another thing is like, I would practice a lot of the past year papers, because the tricks which IB uses, right, they are largely very similar over the years. And if you understand the concept behind the topics that you have for physics, right, I think you'll be able to apply yourself such that you can at least, even if it's not the correct answer for the question, you'll be able to get some partial mark along the way lah. Yeah, physics wasn't easy for me. from secondary school, physics was not my strong suit, but I managed to pull through for IB. Yeah.
Yeah, I mean, adding to that point about IB not being, the end point, it's also I flunked TOK, but I'm doing philosophy at uni. So frankly, IB isn't the be all and end all of everything. It's great to do well for IB. In fact, that will help you along your university application, but it's not really nothing is final if you don't decide that it's final.
I guess this is a follow-up question, right? What is the best way for mastering physics and math? Where is it? What's the best way to master physics and math, like studying habits, tricks, right? For me, at least for physics, right, I went around and I did the past year papers because back then my year was 2020, right? I did the past year papers from 2016 to 2020, and even after I finished those papers, right, I would cycle back and redo them. So because there's always things that you'll forget from the past year papers, and it's actually sometimes quite useful to go through the questions over and over again. I think the key thing that you want to know, to gain from studying this way, is the muscle memory as to how to solve the questions in physics. Yeah, and if you don't understand the concept, I suggest you go to your teacher or look up online as to the concept, and make sure you understand the question first. Understand the concepts before you go and build the muscle memory for these questions. For me, because I was better at math than physics, so I spent a lot more time on physics. Yeah, does that answer your question?
Okay, so I'm going to answer a question. If you guys have any questions regarding IB, you have my email. Just drop me an email anytime, and I will be able to assist you. So I'm going to answer the second half of the question, which is for math, right? You may call me biased here, but I can tell you that if you EdXP will go a long way in helping you. So as you guys know, recently the May 23 papers were concluded, and we have a lot of EdXP students actually messaging me and emailing me and telling me at least how many of the questions that appeared in EdXP, which were created by these guys, for example, Richard and Ben, actually appeared for May 2023 papers. Okay, and the reason why I would biasly, for good reasons, suggest EdXP is because if you look at what's available out there in the market right now, right? If you do not have a strong support system in school, which is what I understand from a lot of students, right? It's okay. I'm gonna just drop my email to everyone here. If not, it's actually okay. What I understand from a lot of students is that either your school teachers, they are new, they are not IB trained, or even if they are not new and they are IB trained, they teach only conceptually, but they don't prepare students for exam questions. So a lot of students actually tell me that while the teachers can teach, they don't know how to answer questions. And then if you were to look for exam standard questions, what are your options? Number one, you can look at past year papers, but because of the revision of the IB syllabus, the past year papers are the latest you can go back is from 2021 onwards, so you don't have that much option, right? You only have that few papers. Number two, we all know about Revision Village. And Revision Village is charging at least 100-200 USD just to have access. And these guys are really just very grateful that EdXP is only a fraction of the cost. So if you have not already tried, we actually do have a 7 days free trial. Go try it, and then you will understand why I strongly believe that it can help you a long way. Okay, and quite a number of students actually told me that instead of using it to prepare for examinations, they actually use EdXP to even learn, right? So they don't even rely on the teachers anymore, right? Because we have questions sorted into 5 levels, so they start learning new topics on their own without being dependent on the teachers. Yeah. Any other questions? Okay, so I'm gonna ask, right? Okay, maybe Richard and Ben, right? If you could turn back time, how would you attempt your IB differently? Or what is your biggest regret in your IB life?
Then go ahead first, or should I?
Yeah, I think you go ahead first. I'm thinking
Okay.
of it.
So I think, I've actually mentioned a little bit about this just now, like seeing IB as the be all and all to everything. Because I think, like, being in Singapore, right, like admission to NUS, the National University of Singapore, it's really, really dependent on the final grades. Grades are king here. So I think to some extent we got into this, we collectively and me myself got into this mindset that, grades are first and foremost, which is not true for university admissions for most countries and not true for life, because yeah, like the US, UK, if you want to get into super competitive courses, you also want to develop your own interests. Like I didn't even know for a long time what course I wanted to apply to in the UK. So that made it very hard for me to write a convincing, coherent personal statement to say that, oh, I have a deep, lasting passion for this subject that I acquired in the last month, right? So I think that's like discovering your passion is important, and IB is, in fact, it's a great way for you to explore that. I did it unknowingly, like had fun with my IAs. I wrote chemistry IAs and math IAs and whatever that I'm proud of, and with, like, to me, like, most people hate IAs because it's just so different from like what you're used to, but for me, looking back, it's one of the most rewarding parts of IB because it allowed me to grow my passions. It allowed me to explore what I wanted to explore and do all this research. It was painful when it was doing it, but ultimately I think I benefited from learning how to do all this stuff.
Okay, Ben.
Okay, I guess I agree, Richard, because like for the last part, basically, IB covers a lot of breadth, and the reason for this breadth, right, is that they want you to explore. They leave the depth of how much you want to go into up to you. They give you the breadth. They give you the starting tools to discover whatever you want to do. But then the depth, how much you want to go into it is actually up to you. And I guess that's really good about the IAs, I guess, because they really help you explore the different subjects and everything. I guess one regret that I had was that, probably similar to Richard, I felt like I spent too much time on my IAs, especially my EE. My EE, I really tried to make something that I tried to do something that wouldn't work out. I tried to force something that didn't work, which basically I managed to get it to work in the end, but only after a lot of time wasted. Yeah, I wasted a lot of time during my IAs, my EEs, and I think I sort of like missed out on quite a lot of other things that other people have done, and feel like that's like one of my regrets Basically, I focused too much on just, oh, this deadline, there's this deadline, there's this assignment, there's this next exam coming up, and it's just always just studying and studying and studying. I didn't really appreciate what I was doing at the time. Yeah, I think that was my biggest regret.
Okay, thank you so much, Richard and Ben.
I see we have another question.
Yeah.
How do you deal with burnout throughout IB? Oh, if you are at the end of IB year one, yeah, I can understand where you're coming from, because it is the year where you already think it's tough enough, but then everybody's just gonna tell you it's gonna get worse. I'm not gonna sugarcoat it. It is gonna get worse, but I guess what gets you through it is like your friends and your teachers, because for me at least, whenever I felt like I was really down, whenever I was feeling very discouraged, I was a mess. I was like struggling to meet whatever deadlines I had. The thing that brought me through it was the fact that, okay, all my friends are still here with me. They are all suffering through the exact same thing that I'm doing. Especially for me, because for me, right, in my class, my combination was exactly the same. So everybody was literally doing the exact same thing as me. I guess you should find your group of friends that will go through this with you lah. And I don't know how well the support system in your school is, but if you have any, like, for me at least, whenever I had any academic problems, I could always go to my teachers for some help and guidance whenever needed. And I think the key thing about not burning out in IB is that you must learn to take breaks. You must know when to say, okay, I'm not doing any productive work anymore. I'm gonna take a break for a day and come back to it. Maybe a day, 2 days later. It's all right to take breaks. You need to keep telling yourself that. Richard, do you have anything?
Yeah, I want to echo the thing about friends. I'm fortunate to be around like really smart people and like really kind people. So I went back to school to talk to like one of my teachers in IB, the same one who marked my eye actually. So she was telling me about how like the batches after me tended not to like they weren't very willing to show their IAs to their friends. Like for me, for my batch, for my friends, we were like, you know, it's cool, right? That it's okay to help each other in this case without colluding or using the same material, of course. But you're not in this alone. And if you treat IB like a solo battle, it's gonna be torture because you're gonna feel alone, right? But it's better if you have the collective wisdom of your friends to help you grasp this the subject or to help you tackle this new thing called the IA or the EE or CAS or TOK, whatever. And also sleep on time. Sleep is really, really, really important. I sacrifice sleep to do a lot of things in Sec 3 and Sec 4, which would be freshman and sophomore years, right? I think for the American system. So I sacrificed my sleep and I realized that, you know, in class I'll be sleeping. So what happened was that I need to spend way more time to go and revise these materials at the end of the year before exams. So it's really an inefficient way. Prioritize and sleep on time. Yeah, and turns out my teacher was pretty good at explaining stuff, so I was missing out on all that.
Yeah, I want to emphasize the point on sleep. Sleep really is important because for IB, right, there will be always 20 million things for you to do at the same time. There's no way that you are going to be able to complete whatever you have on your plate right now. The point maybe is to do what you can, and after that, when it's time to sleep, just let it go and you'll face it again the next day. Yeah.
Okay, thank you so much, Richard and Ben. If I think we've come to the end of this webinar. If we do not have any further questions, all right. If not, thank you everyone. I hope you guys have a good Saturday. Yes, have a good weekend, and summer is coming up, so enjoy your summer. Oh wait, I know that some of you are gonna have some end of year exams over the next 1 or 2 weeks. So all the best to you guys, and then enjoy your summer. And of course, DP2 will start, and that's when your IB exams. Okay, maybe Richard and Ben, any final piece of advice for these IB students, for the DP1 students?
Have fun.
Yeah, I think
learning is not always fun, but do your best. Have fun.
I guess for me is IB seems very challenging if you look at it as a whole, but then it's not so much when you take it step by step. So whenever things look very tough, right? Whenever things look overwhelming, break it down and take it bit by bit. I'm sure you guys will be able to do it. Yeah.